Today we're going to talk about what is the sum of the first n counting numbers. What is this equal? Is there a closed formula for it? Well, I guess before we do any type of a proof, let's motivate the proof. And Dr. Gauss, when he was a student, I think in the 4th grade, their class, he and his classmates were pretty much disobeying the teacher, being rude, and the teacher gave them a punishment policy. Because I don't want you to talk at all until after you add up the first 100 numbers. And she assumed that this was going to take forever. But she didn't realize that she had Gauss in her class. In any case, what Gauss did was he realized that if you add the numbers backwards, that the sum will still be the same. Which most students in the 4th grade would probably know that. But what Gauss realized was that when he wrote it backwards and he added up the numbers, he kept getting 101. Kept getting 101. Even in here, he kept getting 101. 101 plus 101. Well, he knew that if you keep adding the same number to itself a number of times, it would be 101 times that number of times. My goodness, how many times do we get 101? Well, just look for some counter for you. The first time we wrote 101, there's a 1 on top. The second time we wrote 101, there's a 2 on top. The third time, a 3 on top. Oops, we do have a typo. That should be 101. The fourth time we wrote 101, there's a 4 on the top. You know what? The last time we wrote 101, there was 100 on top. That is, we are adding 101 to itself 100 times. So that product, or that sum, is going to be 101 times 100. But Gauss realized, so let me just write this down, 1 plus 2 up to 100. Gauss realized that it won't be 100, the sum of the first 100 integers, positive integers, will not be 101 times 100, because he added what he wanted to itself 2 times. So in the end, you have to divide by 2. And in probably shorter than the length or time it took me to do this, he had the answer. He realized 2 went into 150 times, and that 50 times 100 is 5,000, and 50 times 1 is 50, and he came up with their solution 50-50, and then he called out to the teacher, who promptly scolded him for talking before he finished the problem, and he proceeded to explain to his teacher, the teacher, I have the answer. I added the first 100 numbers. Okay, so now that we've seen this problem to add up the numbers 1 to 100, it might motivate us, or it should motivate us, to figure out how to find the formula to add up to any number. So what we would do is the following: 1 plus 2 plus 3 plus 4 plus 5 up to n. And the number before that is n minus 1. And the number before that will be 1 less, or n minus 2. Now, if we write it backwards, we have n plus n minus 1 plus n minus 2, and so on, n minus 3, n minus 4. eventually we'll get to 3 plus 2 plus 1. And if we call these each s's, when we add them, the left side will be 2s, and on the right side, we have n plus 1. Now if you think about it, if you make this number 1 more, and that number 1 less, the sum's not going to change. If you have some coins in your left pocket and right pocket, and they add up to n plus 1 or 17, if you take a coin from the left pocket and put it in the right pocket, well then the left pocket will have one less, the right pocket will have 1 more, but you still have the same number of coins, whether it be 17 or n plus 1. In any case, n plus 1 again. Or you can do it n minus 2 plus 3, n plus 1. And you keep doing this, n plus 1, plus n plus 1, plus n plus 1. And that 2s is going to be n plus 1, the number we are repeatedly adding, times the number of times we're adding it. Well, again, this was the first time we have a 1 above it. This is the second time we're adding the 2, the third time, the 3. We're adding it to itself n times. So we're going to get, let me just put the n in the front. So we're going to get not n plus 1, but n times n plus 1. And if we divide both sides by 2, which is not s, sorry, we divide both sides by 2, we'll get s is n times n plus 1 over 2. Well, what is s? Well, it says s, that means s is this. That is, this is n times n plus 1 over 2. Now, let's see if this formula matches what Gauss got. Who knows? Maybe it doesn't match. So Gauss was asked to add up the first 100 integers. The n is 100. So we're supposed to get n times n plus 1 over 2. Well, 2 goes into 150 times, and 100 plus 1 is 101. Exactly what Dr. Gauss got. So 50/50. Now, this is one way of generating the formula. Now, suppose somebody told you this. They didn't prove it like we just did. They just said, you know what, 1 plus 2 plus 3 up to plus n is n times n plus 1 over 2. And you're like, you know what, I'm not gonna accept that. I need to see why. And this is the attitude of any good math student. Never believe anything that your teacher tells you. Never believe anything that I tell you. Prove it for yourself. Okay? So this is a fact. It actually is true, but let's prove it. Now, we want to show it's true for n equals 1. Some starting point. Show true for n equals 1. So the left-hand side is just 1. And does it equal to the right-hand side? Instead of n, I'm going to write 1. I'll say n, but I'll write 1. N times n plus 1 over 2. Well, this is 1 times 2. 1 plus 1 is 2 over 2, which is 1. So what we know is that it's true for 1. Now, our induction hypothesis. We're going to assume that the top equation is true for n equals k. So instead of n, I write k. So I get 1 plus 2 plus 3 up to k. This is n times n plus 1 over 2. So for this problem, we're allowed to assume that this is true. Is it true? We don't know that, other than it's true for k equals 1. We know it's true if k is 1. Now, we want to show true for n equals k plus 1. So the top line, instead of n, I'm going to put k plus 1. So 1 plus 2 up to n. That's how I write n. This is equal to, or does it equal to, n times n plus 1 all over 2. That is it k plus 1 times k plus 2? After all, 1 plus 1 is 2 over 2. That's what we want to know. Is the sum of the first k plus 1 numbers equal to this? Well, let's see. 1 plus 2 plus 3 plus 4 up to k, and n plus k plus 1. Well, we have a rule for this. Is k times k plus 1 over 2. And then I have to add k plus 1. I have to add k plus 1. Now, to have the same denominator, I'll multiply by 2 and divide by 2. Now the denominators are the same. So it equals over 2. Now, both numerators have a factor of k plus 1. They both have the factor k plus 1. So I factor it out, and then I write down what's left over, namely what isn't in blue, inside brackets. K is left over, the plus sign is left over, the number 2 is left over. And what I just shown is that the sum of the first k plus 1 numbers equals this. Oh, that's what I wanted to show. I wanted to show that the sum of the first k plus 1 positive integers is in fact that. So I'm done. I proved my theorem. This completes this video. If you like mathematics like this, keep coming back and expect to see more. Subscribe to my YouTube channel. Tell your teachers and friends about it. And please leave a comment below. Okay, thank you.